Welcome back to The Explainer. I am absolutely thrilled to take you on a journey today. Think of this explainer as a structured elevator ride, taking us straight up through the foundational pillars of the modern AI industry. We're going to cover the absolute basics of AI, exploring the core fundamental mechanics of how artificial intelligence actually comes to life. We'll start all the way down at the microscopic silicon chips and right all the way up to the global laws that are shaping our society right now. Okay, let's dive into this. Here is our roadmap for today's ride. We are going to start on the ground floor with the physical hardware driving AI. Then we'll head up to see how we align these models with human values. After that, we'll look at the very real impact AI is having in the workplace today. And finally, we'll reach the top floor to examine how the world is actually regulating this massive revolution. Section 1. The hardware driving AI. All right, so let's start right here on the first floor, the physical infrastructure. It's really easy to think of artificial intelligence as just something floating invisibly up in the clouds somewhere, right? But the basics of AI are deeply rooted in physical reality. To really grasp this foundational layer, we have to demystify the tech. It isn't magic. It is essentially a brand new kind of industrial manufacturing process. We are literally entering the era of AI factories. Just like a traditional factory takes raw materials and uses heavy machinery to build cars, AI factories take raw data and use massive, super efficient supercomputers to manufacture intelligence and reasoning. And just like those old school factories, the sheer scale of the operation today is just breathtaking. Just take a look at NVIDIA's new Blackwell architecture. These are absolutely not your standard run-of-the-mill desktop processors. Systems like these rack-scale supercomputers are massive, high-performance physical engines specifically built to handle the staggering mathematical loads required for advanced AI reasoning. To put this into perspective for you, training a frontier model today, it can consume the equivalent power of thousands of households over several months. It is an intensely physical, resource-heavy endeavor. Without these tangible, high-octane physical engines, the software simply cannot exist. Section 2. Aligning models with human values. Moving up to the second floor of our ecosystem, we're transitioning from the hardware to the software. How are these massive models actually built? Who gets to use them? And, crucially, how do we make sure they're safe? Well, the first major dynamic to understand here is the massive cost disruption happening right this second. Open source AI is fundamentally democratizing the landscape. It boasts dramatic cost advantages in both training and usage compared to closed source models. So what does this actually mean for you and the broader market? It means universities, startups, and mid-sized enterprises can finally meaningfully participate and innovate in frontier AI. We're talking about projects that used to cost tens of millions of dollars to train, now being replicated or fine-tuned for just a tiny fraction of that cost. The monopoly of a few highly capitalized tech giants is being broken wide open. Now, what's really interesting about this slide is the massive contrast in how we actually teach these models to be safe, a process we call AI alignment. Historically, developers leaned really heavily on algorithmic-centric alignment. That focuses on theoretical guarantees, reward models, and super complex optimization math. Think of it like trying to write the absolute perfect set of hard-coded rules. But the industry is making a crucial shift toward data-centric alignment. This approach focuses on the quality, accuracy, and representativeness of the feedback data itself. The core idea is simple but incredibly powerful. To build safer, more reliable AI that reflects a broad spectrum of human values, you have to prioritize highly diverse, reliable human feedback data right from day one. You just can't fix bad data with clever math. The foundation of safety has to be the data itself. Section 3. AI in the workplace. Let's take the elevator up to the third floor. Now that we have the hardware humming and the software safely aligned, how is this actually impacting the real-world labor market and enterprise value today? Look at this number because it is fascinating. 3.5. That is the number of different AI models the average enterprise respondent is using right now. Companies aren't just buying one single tool and calling it a day. No way. They are what we call model omnivorous. They're taking a highly customized portfolio approach, cherry-picking the absolute best specific model for the exact task at hand, whether that's a simple coding automation task or a highly complex, multi-step agent workflow. And the data tells a really fascinating story about this. The way businesses are measuring the value of those omnivorous models is shifting in real time. Just a little while ago, saving time was the big return on investment people wanted from AI. But notice this drop. Early on, time-saving use cases plummeted from nearly 20% down to just 13.6%. Instead,
Increased output and throughput shot up to take the absolute #1 spot. The enterprise mindset has quickly moved away from merely, hey, let's do things faster, toward how can we dramatically increase what we produce. It is no longer just an efficiency play, folks. It is a massive capability multiplier.
But what does this all mean for the workers themselves? Well, a recent Harvard Business School study highlights a very nuanced duality here. Generative AI is really different from past technological revolutions because it specifically targets white-collar cognitive tasks. So on one hand, you have automation, where AI replaces routine tasks like simple coding or basic sorting. This actually decreases the demand for new human skills in those areas because the job functions just become totally standardized. Think of automation as the thing doing your tedious data entry. But on the other hand, you have augmentation. This is where AI complements your human capabilities in complex tasks, like strategic planning or creative problem solving. It acts like your brilliant brainstorming partner. And this augmentation drives up the demand for new skills, making the human worker more valuable than ever. It's a profound shift, really separating those who are replaced by the tools from those who learn to wield them effectively.
Section 4, Regulating the AI Revolution. Finally, we arrive at the top floor of our ecosystem. With hardware scaling up, open source models spreading like wildfire, and the workplace totally transforming, how is the world building the global guardrails to keep this technology safe? Well, it requires massive collaboration. We're seeing corporate boards and policymakers coming together. Organizations like the IEEE are stepping up as the safety inspectors of the AI factory. They're actively developing rigorous global standards. We are talking about standards for fail-safe designs to ensure systems can safely shut down, well-being metrics to ensure AI actually increases human health, and even rules for ethical nudging to prevent AI from improperly manipulating human emotions. It's all about designing these systems with fundamental constraints built right into their core.
So the crucial point is how this translates into actual worldwide law. A comprehensive EY report mapped out this global race to control the technology, and they framed the building blocks of future regulation around 5 key trends. Number 1, a strict adherence to OECD principles, making sure basic transparency and human rights are preserved. Number 2, implementing a risk-based approach, meaning strict rules for high-risk AI like hiring algorithms compared to lower-risk stuff. Number 3, developing sector-specific rules, because an AI tool used in a hospital needs vastly different guardrails than one used for financial forecasting, right? Number 4, deeply linking AI oversight with existing cybersecurity and privacy laws to close any security gaps. And lastly, creating regulatory sandboxes. These are essentially safe play zones, allowing companies to test innovative AI with regulators watching closely, ensuring everything is locked down before it hits the open market. Which brings us to the ultimate question. We've ridden the elevator all the way up, from the physical chips of the AI factory, up through the democratic software models, into the transforming workplace, and finally to global policy. Grasping these basics of AI shows us that this isn't just some regular software update. It is a fundamental shift in our entire industrial and social fabric. As AI evolves from silicon to society, are we actually ready for the factory of the future? Think about where you and your organization fit into this massive new ecosystem, because the factory of the future, it's already running. The only question left is, are you going to help design it, or are you just going to be working on the assembly line? Thank you so much for joining me on this explainer, and keep learning.